minus x. Now summation 0 to n cx, and we will write here the iota I t p power x and q n minus x. Now this is a and this is the b. Then we'll use the binomial expansion formulas. Then it became p iota I t plus q power n x phi xt, the characteristics function equal to p iota I t plus q power n. And there is one more thing. Third is the probability generating function of binomial distribution. This is denoted by gxz or zxt equal to summation of z x gxz equal to expectation of zx summation of x from 0 to n zx px. We expand the px here, x equal to 0 to n zx and ncx px q n minus x. Summation x from 0 to n, here we write ncx into zx px q n minus x. Summation x equal to 0 to n ncx zp power x qx n minus x. Then we use the binomial expansion formulas, and zp equal to p and q equal to p. So g xz or probability generating function equal to zp plus q power n. Now we'll see the mean and variance of binomial distribution. Now we'll see mean and variance of binomial distribution. mean equal to expectation of x. We'll write here summation of x 0 to n x dx. Summation of x 0 to n x and ci x px q n minus x. X and then factorial n x factorial and n minus x factorial px into q n minus x. I further expand this summation x from 0 to n x to factorial n x into x minus 1 factorial to n minus x factorial px q n minus x. Add the x and x. Then summation x equal to x from 0 to n factorial n minus 1 factorial n into n minus 1 factorial by x minus 1 factorial into n minus 1 factorial minus x minus 1 factorial. Here we do nothing but just here the 1 is added here and the 1 is subtracted, so there is no change in here, and we can write px as so p into p x minus 1, and here we also write this in same way, exactly same way, n minus 1 into minus x minus 1. We will take n and p common outside the summation, so the n into p equal to summation x from 0 to n factorial n minus 1 by x minus 1 factorial into n minus 1 minus x minus 1 factorial p x minus 1 into q n minus 1 minus x minus 1 n minus p into summation 0 to n x. So we can write here is n minus 1 c x minus 1 p x minus 1 q n minus 1 minus x minus 1. And when we use as binomial expression, then binomial expansion formulas, then NP, this is considered as A and this is considered as B. Then P plus Q power n minus 1. Since we know the P plus Q equal to 1, then P plus Q power n minus 1 equal to 1. So therefore Ax equal to np into r equal to np. This is the mean per molars for binomial distribution. Now we'll see how to find the variance. Binomial distribution. Sigma x square equal to the variance sigma x square equal to expectation of x square minus expectation of x whole square. So the first we find the expectation of x square, and expectation of x square equal to expectation of x into x minus 1 minus ex. This is mean. Then we first need to find the expectation of x minus 1. Now we'll find the expectation of x and x minus 1 equal to summation of x from 0 to n x into x minus 1 px. Then we expand the px, summation of x 0 to n x minus 1 into ncx and px n minus x. And x into x minus 1 factorial n factorial x n minus x px q n minus x. Here we break the factorial n. Same way to eliminate x minus 1. X minus 1 factorial n x into x minus 1 x minus 2 factorial n minus x factorial px q n minus x. So these terms and these terms will remove. Now the summation x from 0 to n factorial n x minus 2 factorial n minus x px q n minus x. Now we will make this summation x 0 to n into n minus 1 into factorial n minus 2 y factorial x minus 2 into n minus 2 factorial minus x minus 2 factorial, and we also write the px same as p square into px minus 2 and q n minus 2 minus x minus 2. We'll take common outside the summation n into n minus 1 into p square summation x equal to 0 to n factorial n minus 2 factorial x minus 2 factorial into n minus 2 and x minus 2 factorial px minus 2 and q n minus 2 minus x minus 2. This is the same binomial expansion. We can write n minus 1 into p square into summation x from 0 to n minus 2 c x minus 2 p x minus 2 q n minus 2 and minus x minus 2. N into n minus 1 p square. We'll write here the binomial expansion formula. This is the a terms and this is the p terms. So it's became p plus q power n minus 2. And this is equal to 1. The everything power 1 equal to 1. So n into n minus 1 p square into 1 equal to n square p square minus n p square. This is the expectation of x minus 1 equal to n square p square n minus p square. Now the variance x square equal to ex square minus ex whole square, and ex equal to ex into x minus 1 minus ex minus ex whole square. Here this is n square p square minus np square, and this is the mean, and mean equal to np minus np, and here the minus this is not